Okay, all right. So let's talk about the fifth unit of the second chapter, that is functions, and the unit is transformations of functions. Now, in O levels, we also talk about transformations. We talk about rotation, reflection, stretch, things like those. Here again, we are talking about transformations, but this time around, you would not be having a point or a diagram. We would be transforming functions, but the idea is same. The underlying idea is same. We will be transforming a function by moving it from one point to the other, by stretching it, by reflecting it, and we need to see what impact that would make on the function. Okay, so just by changing the sign, just by adding something, subtracting something, you will see that on the graph your function would be transformed. It would still be quadratic, but it would either be shifted, reflected, stretched, it would get small. Things of this type would be happening. Right now we have a variety of transformations. We have translations, we have reflections, then we have stretch, and then we have combined transformations and stuff like that. Today we will be talking about translations. Okay, every transformation has its own impact. Let's talk about translations for now, and every topic would be discussed in detail. So this is the first type. It's type number 1, and it is called translations. Now, some of you would be knowing that what exactly a translation is. Like when we say translations, basically, if you have a point, it's basically shifted to another point. Or if you have, let's say, a circle or a curve, it's just shifted to another point. But what impact would it make on the equation of that function? Okay, so the question could be either way. It could be that you have a function, then you have uh, a changed function, and the examiner would want you to plot both the functions. Or it could be that both the functions are plotted and you need to write down the new equation of the function. So it could be of this type. Anyways, let's just talk about question number 1, and then things would make sense. Okay, imagine that you have two equations. So it's the original one is y equals x squared minus 2x plus 1. This is the original equation. And now I am going to write down another equation, x squared minus 2x plus 1 plus 3. What is the difference in both the equations? The difference is that I have added a positive 3 and every other thing is same. This is still quadratic. The basic idea in this curve would still be same, but I have just added positive 3. What impact would this positive 3 is going to make on the graph? Let's talk about that. Okay, so imagine, let me make the graph of both the functions, and for now let me just do it directly. All right, this is equation 1, and then this one is equation 2. If I say that the graph of equation 1 is something of this type, I'm just making a rough graph to explain the idea. It is actually something of this type. Why and how exactly I made this graph, forget about it for now. We are not discussing the making of the graph. Okay, we'll talk about it later on if you have any questions. Although it's easy, again, you need to, either apply the completing square method or factorize. We have multiple ways. We'll talk about it later on. For now, just trust my words and know that this is the graph of the first function. Okay, this is the graph of first function. I've made that for you. This is the graph of the first function. Using this graph, now this is the challenge. Using this graph, I need to make the graph of this equation. How do I do that? I know that the only difference in 1 and 2 is of this positive 3. So the rule says, I will be stating the rule after this example. The rule says, whenever we are adding the value to the entire function, like this positive 3 has been added to the entire function, my graph will shift those many units above. Okay. So let's say this is 1. Let's say this is 2. And let's say this is 3. This point would be shifted to this point, and every point would be shifted accordingly. Okay. I'm just explaining the idea. It would be something of this type. So the difference would be of 3 units. What has happened? Both the functions are same, both the equations are same. The only difference is of positive 3. So the basic shape of 1 and 2 would be same. The only difference would be that since I've just added a number to the entire function, my graph would move those many units above. Similarly, if I talk about another equation, y equals x squared minus 2x plus 1, and let's say minus 2. So what's happening? Everything is same. Still the equation is same. The only difference is that I have subtracted 2. So the difference in 1 and 3 would be of that this blue graph would be shifted 2 units down. So imagine this was 0. This is 0 obviously. Then this is minus 1. And this is minus 2. Now my graph would be made somewhere over here. So it would be something of this type, right? The difference would be of 2 units. So what has happened when I've added positive 3? The graph has been shifted 3 units above. It's just a rough sketch. And when I've subtracted 2, I've moved the graph 2 units below. So this is basically the idea about translations. Now this positive 3 and negative 2 was added in the entire function. If I will add or subtract something in x, things are going to be different. Okay, things are going to be different. We'll talk about everything, but before that, let's just talk about the definition. Okay, so you need to remember this is a key point. Number 1 for translations, the graph of y equals f of x plus a is a translation of the graph of y equals f of x by the vector 0, a. Okay, let me explain this to you, but trust me, this is very important, and this key point itself would be used in your paper, right? These exact words would be used. The examiner would ask to comment on the type of transformation, and there you will be telling if it would be a translation, a reflection, a stretch, or whatever it would be. So if it is a translation, you need to explain that it would be a translation, and you need to give the translation vector. Okay, just like in O levels where it used to be rotation, we used to talk about the center of rotation and some other details. So some details are related to every type of transformation. Where it would be about translation, we will be talking about the translation vector. Okay, now what has happened over here? We have added a to the function. How? Just like this, I added this positive 3 to the function. I subtracted this negative 2 in the function, right? Similarly, whenever you are adding any number in the function, the graph would basically be a translation of the original one. So the shifting of graph 3 units above from this to this was basically a translation. When you are shifting it left, right, up, down, I'll talk about left, right later on, but up, down, it would basically be a translation. Okay. It is not stretching. It is not squeezing. Or I agree my graph looks like this, but I'm telling you, everything is just a shift. And that's why we don't call it a shift. We call it a translation. Now, whenever we talk about the translation vector, if I talk about the translation vector, translation vector has two coordinates. This is the x coordinate and this is the y coordinate. Okay, since we have just added an a to the function, it means we have just added a number in y. Basically, we have just added a number in y, so we only have a over here where we have y. Okay, in translation vector we have two coordinates, we have x and we have y. It could be that the translation is both in x and y. I'll come to that later on. For the example that we have just discussed and for this key point number 1, just know whenever you are doing anything in the y-axis, whenever you are adding something to the function, that would basically mean you're adding something to y, or you're subtracting something to y. You will be writing this down number over here, and every point, this vector is added to every point of the graph. For example, if I talk about this point right here, this was the original graph, this blue one. If I talk about this point was, let's say this point originally was 0, 1. Yes, this point was 0, 1. This is 1. This is 1. Okay, this point was 1 and 0. We are going to add the translation vector, which would be 0, 3 for this scenario. And when I will add 0, 3 to this thing, basically x is 0 and y is 3, this point would become 1, 3. You can clearly see that this point is 1, 3. So every point would be shifted this way, but we don't talk about it this way. Just know in translations, things are shifted either left, right, or up, down. We have a translation vector. Translation vector has two coordinates, again, the x and y. Whenever you are adding something to the function, the change would be added in the y coordinate, and whenever we'll be doing something to the x axis, it would be added over here. Any confusions for now?
No, miss.
Munja, Ahmed, Motasam, please tell me if you have understood this or not.
I have
Understood.
Yes, okay, all right. So I hope that this is clear. Okay, this was just the first thing. Now let's talk about another scenario, and then things would make much more sense to you guys. Okay. Now imagine case 2. This is type 1, but this is case 2, okay? Or let's say you can think about it as example number 2. For example number 2, the original function is y equals x squared minus 2x plus 1. This is the original function. And if I talk about the translated function, so that is x minus 3 squared minus 2 x minus 3 plus 1. What is the difference? Everything is same. The only difference is that now instead of x, I have x minus 3. Instead of x, I have x minus 3. So what change or what difference would this change make on the graph? Okay, everything is same except this, that I've subtracted 3 in x. This time around I've subtracted 3 in x. In the previous, or in the first example, I added 3 to the function. Okay, whenever I would be adding something to the entire thing, that would be adding 3 to the function, and whenever I would be doing something with x only, that would be adding or subtracting with x. Let's see what change would this make on the graph. Again, let's just talk about it quickly. So I won't be needing the negative y-axis. This is the y-axis. This one is the x-axis. Let me make, this is 1 and this is 2, okay? Let me just quickly make 1. 1, for instance, is this. Just trust my words and know. This is the shape of 1. Now, you know that this is the graph of 1, the red one. How? Forget about it. This is the graph of 1. How can I make the graph of 2? By knowing that the only difference in 1 and 2 is of that I have added -3 to x. Now, students, things are different for x. Just know, whenever you are adding or subtracting something in x, your graph would be shifted left or right. Whenever you are adding and subtracting in the function, your graph would be shifted up or down. Okay, so now I know that I have subtracted 3 in x, so it would either move right or left. Can anyone guess? What would where would be the new parabola made? Would it be made on the right side of the red one or on the left side of the red one?
I think it's on the right side.
Okay, and what about the other students? A random guess?
Left. I think left.
Okay, left
I
makes
think it
sense.
moves to the
Okay, okay, okay. Very good, all of you. -3 would make you definitely think that this graph should be shifted towards the left side. I totally agree. Everyone would say that it's -3. And when we had -2, the graph was shifted, 2 units down. So this time around, it should move 3 units to the left. But unfortunately, this is not the case. For x, things are different. When I'm telling you for x, things are different, you will get to see that in every transformation. Whenever we will be multiplying 2 in y, it would be stretching. But whenever we will be multiplying 2 with x, the graph would basically be squeezing. So it's opposite for x. This time around, we are subtracting 3. When we add or subtract something, that's basically translation. And technically, it looks like it should go to the left. But that's not the case. Motasam was right. It would move towards the right side because things are different for x. Okay. So just know, whenever you are subtracting something with x, it would go those many units to the right. So this was 1. And now this point would basically come at 4. Let me just make the graph for this one. And it's going, let's say this is 4. I'm sorry about my drawing. This is 4. Now this point has been shifted to this one. Why? Because we have subtracted 3 in x. Why did this graph go up or down? Because we did not add anything or we did not subtract anything in the function. We just subtracted something in x. And why did it go towards right? Because this is how it is for x. It's other way around. Okay. This is what we need to remember. All right. Now let me just write down 2 more key points and then we'll talk about some detailed examples. Key point number 2. The graph of y equals f of x minus a is a translation of graph y equals f of x by the vector a0. Now what has happened? F of x minus a and f of x. Again, what is the difference? The difference is here we have x and here we have x minus a. This is the difference. Okay. And whenever we are subtracting, look at this. We have positive a here. So all the points would basically be moved according to this translation vector. And this is how it is. Okay. Now imagine if we had positive 3. Let me just write down one last scenario. X plus 3 squared minus 2 x plus 3 plus 1. Now you guys would be knowing where it was minus 3, the graph shifted towards the right side, it's 1, so it would basically come 1 0 minus 1 and we have minus 2. Okay, this would basically be the point. And if I talk about this point, so the graph would again be of the exact same shape. The only difference would be that all the points have shifted a little bit towards the left side. So that is true. But if I talk about that you need to write down the translation vector for this third equation, how are we going to write it down? We know that the translation vector has two coordinates x and y. Nothing has happened to y. We did not add or subtract anything in the function. So this would remain 0. And since we have added 3, so this would become negative 3. For negative 3, it was 3 directly. And for positive 3, we are going to write down minus 3. Why minus 3? Because every point has been shifted towards the left side. If I talk about this one, now I am at minus 2 means that I did 1 minus 3 and that is how I got minus 2, right? So this is basically the idea about writing down the translation vector, and it would get even better with time. All right, okay. Anything that is coming to your mind, any confusions?
No.
Okay, perfect. And this, for now, we have discussed two scenarios. For the first one, we made a difference in the y-axis by adding or subtracting something in the function. Then with x directly, but what if we do both? What if we do both? Okay, so for that, I'm directly writing down the key point. And trust me, this is important. The graph of y equals f of x minus a plus b is a translation of the graph y equals f of x by the vector AB. Okay, now what has happened? We have subtracted something in x and we have added something in the entire function. So whatever we added in the function has been written directly, and since we subtracted something in x, things are other way around, so we have just written this a. So we have just combined both the concepts and this would be the final idea about it. Okay. All right. Okay. So this would get clear once we will do more questions. Don't worry about it. Let's talk about an example now. Okay. Question number 1. Question number 1 says, the graph of y equals x squared plus 5x is translated 2 units to the right. Find the equation of the resulting graph give your answer in the form y equals ax squared plus bx plus c. Okay. What is this question saying? The graph of y equals x squared plus 5x is translated 2 units to the right. Find the equation of the resulting graph. Give your answer in the form y equals ax squared plus bx plus c. Okay. All right. Now, again, this time around, although they did not give the graph, but they have just elaborated, they've just, explained whatever would be happening in the actual graph. Okay. This is the original function, and they have told you that you would be moving it 2 units to the right. Can you guys try doing this question? Just try doing it. I'll give you 2 minutes, please. Yes. Any idea what would be happening? Okay. Just remember my words. I told you whenever your graph would be translated or moved or shifted towards the right side or the left side, it would basically mean that the change would be made in X. The change would be made in X, okay? And when it says 2 units to the right, so this time around your graph is moving towards the right side. And when it is moving towards the right side, we are actually doing other way around. If I talk about the thing, imagine that, let's talk about the solution. It is y equals f of x, and when we are translating it 2 units to the right, it would become y equals f of x minus 2. Okay, this is the original curve. When we are translating it 2 units to the right, right means minus, and 2 units mean 2, right? This would be happening. So I need to write it down this way. It would basically become y equals x minus 2 squared plus 5 into x minus 2. Now, obviously, I need to expand this entire thing because I've been told that I need to give answer in this form. So I can write it as y equals x squared minus 4x plus 4 plus 5x minus 10, and it would become x squared plus x minus 6. So this would be the new graph. So this is the last thing for today. Let me just explain this again, and then you guys are free from my side. The original graph was this, or the equation of the original graph was this, and when this would be transformed, it would basically be translated 2 units to the right. For now, you have just studied translation, so you know when it is translation and when it's right or left, it would basically be all about adding or subtracting something in X. Just remember, right is minus, okay? Right is minus and left is plus. Right is minus and left is plus. The units were 2, it is right, so we are going to find out f of x minus 2. I've just plugged in x minus 2 in the function and I've just expanded it, and this is what I got. I had to expand it because I was told that I need to give the final answer in this form. Yes, students, anything that you were not able to understand over here?
No, miss, everything's clear.
Okay. All right. Okay. One last thing. I'm sorry. One last thing. It's question number 2. The graph of y equals root 2x is translated by the vector. Now the translation vector is given -5 and 3. Find the equation of resulting graph. Okay, this is basically the original equation or the equation of the original graph. This is your translation vector. I've told you this one is for x, this one is for y. If it says -5, it would basically be let's say it is y equals f of x. So for the transformed version, it would be y of, now we have made a difference in x and we have also done something with y, okay? Whatever would be happening with y would come as it is. So we have a 3 here. I would be writing a 3 here. But we have -5 here. So I would be transforming it x plus 5. We know that whenever we have +5, it would basically be shifted towards the left. And in order to shift it to the left side, every coordinate would be moved 5 units to the left. So that's why it's -5. Okay, I know initially it would be a bit complicated, but things would get better. Just know things are opposite for x. So if you have -5 with the translation vector in the original function or in the resulting function, your difference would basically come by adding 5. Initially we had -5 in the translation vector, but this difference would be made on the graph by actually writing it down this way. Okay, and now we are just supposed to write it down this way. So it would be y equals root 2, and instead of x I'll be writing down x plus 5, and I need to add 3, and I am just going to modify it a bit. So it would become 2x plus 10 plus 3. So this is going to be the answer. So again, this time around the transition vector was given. Please make sure that you know if you have -5 in the translation vector for the x coordinate, it would basically be +5. It's opposite. For x, it's opposite. And same would be happening in all the transformations. You will see it would be opposite. It would be other way around. Okay. So any confusions with this?
No, miss.
Motasim, Ahmed, and Munja, please tell me if you have understood this or not.
I understand. Thank you, ma'am.
No, ma'am.
Okay. All right. Okay. So I hope this thing is clear. Let me stop the recording.